Hello everyone, this video is about Chapter 5, Continuous Random Variables. In this chapter, we will consider some continuous random variables that are commonly encountered. Recall that the discrete random variables are those with countable number of values, integers only. Continuous variables value to many decimals. In Chapter 4, we have learned that the binomial distribution can be shown in this graph like this, where x-axis is the number of successes and y-axis is the probability of x successes. Note that the height of each bar is the probability. The graphical form for the probability distribution for a continuous random variable can be expressed by a smooth curve. The area under the curve is the probability that x is between A and B. Note that the probability is the same regardless of whether or not you include the endpoints of the interval. As we know, the total probability will be 1. That is, the total area under the curve will be 1. The most important and most widely used distribution in statistics is normal distribution. It plays a very important role in the science of statistical inference. The normal distribution is bell-shaped and is perfectly symmetric. The middle will be the mean, and it will also be the median and mode. Because it is symmetric, and the total area will be 1, then each side will be 1/2, say 50% or 0.5. The simplest case of the normal distribution is the standard normal distribution, which has a mean of 0 and standard deviation of 1. We can convert all normal distribution to standard normal distribution using the z-score. The formula is like this, so that we can use the z-table and find the probabilities. That is, z-score will be equal to x minus the mean and then divided by sigma. In the z-table, inside or the body of the table give the area between 0 and the z-score z, which is the probability. The z-score are listed in the left-hand column, which is the z-score first decimal, and in the top row, which is the z-score second decimal. Now let's see different cases. When z is smaller than a positive number, the area, the probability, will be 0.5 plus the value in the body of the z-table. When z is bigger than a negative number, the area, the probability, will be 0.5 plus the value in the body of the z-table. When z is bigger than a positive number, the error, the probability, will be 0.5 minus the value in the body of the z-table. When z is smaller than a negative number, the error, the probability, will be 0.5 minus the value in the body of the z-table. Note that the last z-score in the table is 3.09. That is, for any number bigger than 3.09, the two-tailed area, the probability, will be smaller than 0.01. When z is between two positive numbers, the area, the probability, will be the difference of the values in the table corresponding to the two z-scores, B and A. Similarly, when z is between two negative numbers, the area, the probability, will be the difference of the values in the table corresponding to the two z-scores. So for any case, please draw the curves and highlight the areas. Therefore, for any normal distribution with any mean mu and any standard deviation sigma, we must first convert that value of x to a z-score, which is z equals to x minus mu and divided by sigma. After that, we draw the curve and highlight the areas, and we will know the area using the z-table. Sometimes you will be given a probability and will want to find the values of the z-score. It is critical to correctly draw the normal curve and highlight the area. The placement of z0 to the left or to the right of 0 is the key. Be sure to shade the area correctly. If it does not agree with the probability, then we need to place z0 on the opposite side of 0. For example, if the shaded area is greater than 0.5 and the probability you draw is smaller than 0.5, then you should place z0 on the opposite side.